did how did I do this? I did the first side of this worksheet with you guys, and I did the back side with 9th period on Friday, so I did record both already, but it's good to write. So x equals negative b over 2a is the x coordinate of your vertex. So if I kind of took this problem and used that method, a, b, and c are the same as what they've always been. So what's b in this case, Aiden? Good, so x equals negative 112 over 2 times, what's my a value, Nate? Nope, negative 16, good. So if I calculate that, negative 112 divided by what's going to be negative 32, I get the same 3.5 that I got by going halfway between the zeros. So if you don't want to solve for the zeros first and then go halfway between them, you can just jump right to this formula, negative b over 2a. So it's going to be a new flashcard, x equals negative b over 2a if you see vertex. Now, that obviously only gives you the x coordinate, but just like we did the other day, once you have the x coordinate, that's the input, so that's your t value. You just plug it back in and you get your height at that time. You get your y coordinate at that x coordinate. Is that clear? Okay? So that's all algebraically, and honestly, only if they say that you have to do it algebraically do you have to do that. Because if they don't say algebraically, the easier graphing way of doing this is just by typing it into your calculator. And negative 16x squared plus 112x, we can just graph this. Now I'm going to start with a negative 10 to 10 and a negative 10 to 10 graph. Did I type that in right? Negative 16x squared plus 112x, I did. So I start with that graph. I obviously don't see the whole thing, right? Here's something that needs a great deal of work that we're notoriously weak at. I wish it was ironed out in Algebra 1, but it's been a while, so maybe it was, and now we just forgot. How to set your window so that you actually see the parabola, okay? Clearly, this doesn't look like a parabola to me. It looks like this weird straight line, right? Okay? Couple things, the most important things to help you get an idea. Look at your y-intercept. Are you guys aware that your y-intercept is always your c value? Because what does your flashcard say about y-intercept? Set x equal to 0, right? If you plug in an x of 0, it's always going to cancel out the first two terms of a quadratic. Your x squared term and your x term are going to cancel out, and you'd only be left with your c value. So your y-intercept is always your c value, which is a 0 here. So I'm seeing that. Why am I not seeing the graph? It's so close to the axis, so I'm not seeing it. Okay. So it's here and here. Now, what I'm missing is the vertex. And the vertex, the zeros and the vertex are the three things you want to see the most. Okay? Tell me what you know about the a value. When a is negative, if you have a negative a value, what does that mean about the way your parabola opens? Does it open up or open down? Down. Negative a values open down. Positive a values open up. Again, that's something that you should have learned in Algebra 1. If it looks familiar, good. If not, we got to learn it, and I'm also adding that to a flashcard. So I'm going to put a value. And on the back of that flashcard, positive a, have a little picture next to it that opens up. Negative a value opens down. Okay? Hugely important for you to come up with shortcuts. So given that this is a negative a value, this is opening down. So my vertex, it's either doing kind of this sort of thing or it's doing this sort of thing. And so I clearly just need to see further up. So which axis if I need to see further up, which axis do I need to see more of? The y-axis. So when you go to your window, you got to go to your y minimum and maximums, and you've got to increase, especially the maximum. I don't care so much about the minimum, knowing that my maximum's up somewhere. So if I go up to 50, and you might need to play with this, 50 might not be enough. So there it just shot up. I could see that, and then it shot down. Was 50 enough? Do you see your vertex? No. Now, since we already found our vertex, you won't have always done this. Since we already found our vertex, I know it's at 196. So I'm going to go to 200 just to make sure I see it. And then here's a much better version of our parabola. Nathan. You can and you can't. Oftentimes that will work, but there are situations where that doesn't work and you need to know this. So I'm just going to go this route with it so that we can think logically about these A values and your intercepts and how they're going to help us fit the window. That is a shortcut, but it's not always going to be effective. Okay, so I want, this is the logical way. If you depend on your calculator too much and then it fails you and you don't have the ability to think around it, that's a dangerous spot to be in, especially on these Common Core exams. So there we have it, and now back to finding your vertex. Our favorite menu is second trace. Which one of these is going to allow me to find the vertex? Maximum. Sometimes it's the minimum. If it opened up, it would be the minimum. If it opens down, it's the maximum. And so this one is a maximum, and you're always asked, bring your cursor to the left of the maximum. Right now my cursor is at 0, 0. I can see it blinking, so I have to scroll right. So my cursor is to the left of the maximum. That looks good. And then it's going to ask for my right bound. Scroll my cursor to the right of the maximum, enter, and guess you can just hit enter through, and there it's going to give me my vertex. 3.5, right? We can all agree that 4.4999999 is 3.5, and then 196. Any questions on that? So if you need to find your vertex and it doesn't specify algebraically, please use your calculator. If you can't seem to find a window, though, and your calculator is failing you, or you're failing your calculator, whichever way that works, then you always have the negative b over 2a method to use as like a plan B. But if it says algebraically, you either have to do your zeros and find halfway in between, or jump right to the negative b over 2a method. Are we good with that? Any questions? So that's really kind of what we missed on Friday. We got to this half pipe one, right? Okay. I think we were sort of rushing through this, so I want to see if there's anything we missed. Label its height at its endpoint, so we just found the y-intercept and then the 20. Knowing that this was a 20-foot wide half pipe, we found 0, 7, and 27, so we found our endpoints. And then, again, the minimum point, we traced the vertex, we found the minimum. Okay? Here's another thing. Anytime you read maximize or minimize, write this down. Minimize. That means find the vertex. That is what that means in math. If you want to find the maximum point or the minimum point on a quadratic, that's find the vertex. So a lot of your homework was finding this vertex, finding this vertex. You could use your calculator in second trace, or you could use your negative b over 2a, which you didn't know at the time in your defense. So that's why we're taking another day. Any questions on that? All right, now let's flip to the back. We're going to, like I said, there is a video for this already online because I did this with 9th period on Friday, but we're going to talk through it. Algebraically determine the temperature. So let's go back and look at this. T is your temperature that you're going to pop popcorn at, and the paragraph explains this. And P is the percentage of popcorn that gets popped at that temperature. All right, so algebraically determine the temperature at which the highest percentage. when you see highest or lowest, that is maximize or minimize. That is vertex stuff, okay? So the highest, so we need to find the vertex. It says algebraically, so we're going to do negative b over 2a, which is going to be negative 2.8 over 2 times negative 1 over 250. Kind of annoying because there's a mix of a fraction and a decimal here, but you guys always have your calculator, so you should have no problem typing negative 2.8 divided by, and when your denominator contains more than one thing, keep the whole thing in parentheses and just do 2 times negative 1 over 250. Keep your entire denominator in parentheses. If you don't, it's just going to divide negative 2.8 by the 2, and then it will multiply by the negative 1 over 250, and that's not going to be the right answer. So we get 350. That's our x-coordinate. In this case, it's technically our t-coordinate, so that's our temperature, 350 degrees. We need to find the y-coordinate, the percentage, by plugging in that 350. So P is going to equal negative 1 over 250 times 350 squared plus 2.8 times 350 minus 394. And when I type all that in, and you guys can just watch me do this because I know you all can press buttons, I get 96. So 96% of the kernels are popped at a 350 degree temperature. Okay? Now, use your calculator to sketch. When I type this in, and again, just watch me. Just sit back and watch. You don't need to do this. But what I want you to tell me is, what do you know about my window? If I do zoom 6, I'll tell you I'm not going to see anything. What was my y-intercept? Negative 394. So of course I'm not seeing anything negative 10 to 10. So maybe I go on my y-axis negative 400 to positive 400. Remember, your y-axis stands for percentage, right? Actually, don't need to go past what percentage? I don't really need to go past 100%, right? I will just to see what's happening. But then my x-coordinate stands for the temperature. Already, our temperature that we calculated was 350. So the temperature of your popcorn popping could be anywhere from 0 to, let's say, 500 degrees. And now when I graph it, do I see a parabola that fits this scenario? Absolutely. Okay? Obviously, this part is most important because I'm not going to pop a negative percentage. Does that make sense? Okay, so coming up with the right window is underratedly important. You have to think about it. There's no every problem's different depending on the context. And because we're talking about temperatures, 400 degrees is appropriate. So there's my sketch, and I would just probably sketch this right here. This is my percentage, and this is my temperature. Using the 0 command, I'm very interested in zeros always. Okay, so second trace, 0. Left bound and right bound here is going to give me 195. So that's happening at 195 degrees. And if I do it again, second trace, 0 for my other 0. I just set my left bound really early, but it's taking a while to scroll over. I just hold it down. It moves. I just need to get below the x-axis, which is going to be off my screen. No big deal, I don't think. Or is it? Oh, yeah, it is. It's got to be on my screen. So since that's not on my screen, I need to look a little further to the right. So now I'm going to change my window, and rather than going to 500, I'm just going to go to 600. And then I'll get that 0. So left bound, enter, and then get to the right of that. Perfect. 504 degrees. So at those two temperatures, what percentage of the popcorn is getting popped? 0. 195 is probably not hot enough, and 504 degrees is probably so hot that they all lit on fire and never popped. I'm just guessing. I don't really know. But so if it's too hot, you're going to get burned kernels and it's not really going to be considered popped anymore. Does that make sense? Okay? And the optimal temperature is right here in the middle. So your homework for tonight, and that you'll have a homework quiz on tomorrow, is that same worksheet. So go back through now knowing a little bit more than you knew on Friday. Okay?